I'm Dr. Phil Howell, a plant breeder at NIAB in Cambridge, and I'm going to speak about crop improvement and pre-breeding. I'll discuss different crops and their uses, the process of crop improvement, and why it's important, and then discuss some of the challenges and opportunities as we move forwards. Crops are the plants grown by farmers, and these provide us with food and drink, feed for animals, fuels for vehicles, heating and power, and fibres and other manufacturing materials. In the UK, the most widely grown crops are grass, cereals such as wheat, shown here, barley and oats, oilseed rape, maize, but most UK maize is used for animal feed or for biofuel production, potatoes, sugar beet, peas and beans, and other vegetables. Our growing population needs healthy food and space to live, but we must also protect our wild areas. This means our crops need to become even better at delivering our needs from a limited area. That needs crop improvement. We can improve our crops by increasing yield, basically how to turn sunlight, air and water into energy. We can increase quality, flavour and nutrition to make these crops useful and good to eat. And also, crops can be improved by decreasing the losses caused. For example, if they're attacked by pests and diseases, harmed by heat, cold, drought or flooding, or spoiled just before or after harvest and during the time they're stored. Crop improvement research runs right along a spectrum. At the beginning, you have plant science, discovering how plants work, measuring their differences, and identifying positive and negative features. Then there's pre-breeding. That's what I do, making crops better using the results of the science. And finally, commercial crop breeding, which makes the crops even better, checks that they're suited for farmers, and ensures that only the very best are sold to farmers. So pre-breeding is risky and long-term, so I don't expect quick results. And it provides more the parents and grandparents of crop varieties that farmers are growing. It doesn't provide the varieties themselves. But having said that, it's a vital source of new weapons in the battle against pests, diseases, and the challenges of climate change. And it's essential for providing the raw materials for future crop varieties. But it needs our help. We need to conserve the wild relatives of our crop species so that we can use the rich diversity captured within them to help improve the crops of the future. At NIAB, we use a range of different sources of variation in our crop pre-breeding. The simplest is to use things like land races and old varieties, which may have some good characteristics that have since been lost in modern varieties. We can also use genetic stocks like mutations, which allow us to change specific targets. We spend a lot of time making wide crosses, often with the wild relatives of our crops, to bring in variation from those species. One particular example is resynthesis. This means rebuilding the complex genetics of wheat from its ancestors, which were found in the wild. And we also view GM and genome editing technologies as valuable sources of variation that we may be able to use in the future. So our pre-breeding work has already given us thousands of diverse new types, and crop breeders are exploring what they think the best ones are. But they tend to concentrate on targets like yield improvement, and they might have missed other improvements in things like flavour, nutrition, or crop resilience. And we must investigate those difficult areas too. So can we involve more partners in the way we do this work? Should we involve growers more directly? The people who supply ingredients, who make our food and who sell our food, and in that way change the priority of what's important in the varieties that we produce. With climate change, a move to reduce inputs, and of course Brexit, there are many challenges facing UK farming. So we think that as well as our current familiar crops, we may soon see changes, such as crops for specialist markets, producing valuable items but which are needed in smaller quantities, local varieties with short supply chains. These would be selected and grown close to the processor and manufacturer. There's a definite requirement for plant-based protein, which would come from different types of peas, beans and lentils. And perhaps some of the crops more familiar overseas will become widely grown over here. Things like maize for grain, soybean, sunflowers and hemp. We believe rapid progress is possible if we use the best current research. Things like speed breeding and smart genetic selection, using complex crosses based on some diverse source material. So really it's all about marrying new technologies with our existing skills and experience and applying this to these new crop opportunities. We can also consider different models of funding and revenue. For example, participatory selection, where growers and end users have much more input into the decision making, which may change the priorities we put on our varieties. And perhaps we should view different products rather than monocultures. There needs to be more research done on the environmental footprint of mixed populations or blends of varieties, and even intercropping, blending different crops together, growing them in the same field. So to finish, just think about the world around you. Look around at your food, your clothes, your belongings, and think about how much we already depend on plants for these, and how much plants can provide us in the future. Thank you very much.